This is day 2, 6.5b, we're calling it. Now, this is the Algebra 2A class. So if you're looking for Algebra 2 regular, search up 6.5, and it should be on the YouTube channel somewhere. So yesterday I condensed. I was given something really long and I had to make it smaller. Today I'm given something shorter and I have to make it bigger. So what I'm going to do is just think like here, product property. I need to make it an addition problem. Can you guys just tell me what two numbers multiply to make 6? Just give me 2 and 3. Great. I'm going to make the 2 and the 3 a addition problem. Ready? This, by the way, is base 10. Log of 2 plus log of 3. That's it. You could have even picked 6 times 1. That would have been fine. It would have given you the same value. All right, what two numbers make 45? What multiply? Multiplication problems.
5 and log 9.
So now I'm going to make it an addition problem because I'm expanding it. Oh, base 7. Pardon me. Make it an addition problem. Okay, 5 times x is 5 and x. Make it an addition problem. Yeah.
Like, does it matter if they add a number, like log something?
Base? You mean the base?
Yeah.
The base doesn't matter. It's just going to be the big numbers that we focus on.
Do we have to put the base?
You have to put the base. That's like part of the log base 2 of 5 plus log base 2 of x. Okay? So just making it longer. That's it. Number 10. Can you think of a fraction that reduces to 4? Because remember, we're doing quotient. What fraction reduces to 4? 8 and 2. Or what were you going to say? 16 over 4? Okay. So here we go. 8 over 2. I'm making a subtraction problem. Log base 8 of 8 minus log base 8 of 2. So I made it into a subtraction problem because 8 came from, and that one would have been weird. Like you might have done 2 times 2. You wouldn't have known. I think I like 11 and 12 a lot better because they're clearly fractions. Make it into a subtraction problem. 1 minus 3. Log base 5 of 1 minus log base 5 of 3. 1 minus 3. Fraction means subtract. Go ahead.
Oh, I was just confused. I thought you had to find like something that reduced to 1/3. So like.
Not in this case. Like you could have done, I don't know, 3 over 9.
Yeah.
That would have actually gotten me the same value if you punched it in a calculator. But all right, m minus 7.
Is it log 10?
Yeah, this is base 10. Just m minus 7. That's it. Okay. 16, 17, 18. You need to put the exponent in front. Put the exponent in front. Put exponent in front. The 7 moves to the front. 7 times log base 2 of 8. Right? X minus 1 moves to the front with the 3. Ooh.
That would be negative 3.
No. Can you just make 3 with x minus 1 like that?
Oh,
You could even write 3x minus 3. But in front must be a 3 and an x minus 1. Log 4. and you're done. What's this W if I make it a fraction with an exponent? 1/2. Are we clear on that? The 1 is here. It's a square root, 1/2. Ready? The 1/2 goes in front. Log base 7 of W. That was kind of tricky,
Yeah.
right?
So I can be on the test. Oh, good.
Any of this is fair game for a quiz. Like, I'm not teaching you anything that's too hard. Where I'll be like, oh, this is too hard for you. I would never do that. You guys have calculators? I'll use 12.
Yes, ma'am.
Go to this page. Okay. Change a base means when we can't simplify a log. So here we go. What if I gave you log base 2 of 9? Okay, so I'm like, you guys solve this. And you're like, okay, 2 to the what equals 9? 2 to the what equals 9? And you sit there and you're like, nothing. This is something you can't even solve. The way it looks, you can't even solve that in a calculator. So what we have to do is we have to change the base. I don't want to use base 2 anymore. So here's what happens. I'm going to have the big number on top be the numerator, and the little base becomes the denominator. We saw this yesterday right here. Where I did like down here in notes, A was on top, B was on bottom, and now they both become base 10, and that's something I can actually put in my calculator. So here's this one. 4 to the something equals 8? Nothing. We can't do that. 4 to the... No, like actually...
4 times.
So I do change a base. You make the 8 the numerator, and you make the 4 the denominator. Like that. So can you guys put that in your calculators? Log 4, whoa. Log 8 divided by log 4. So you push the log button. Log 8. Close parentheses, please. Divided by log 4. Close parentheses, please.
We have to.
The answer is 1.5. Try without and see if you still get 1.5. I just like to be thorough, so I'm always going to close it because I'm...
1.5.
Okay.
But it doesn't work.
Log base 6. This becomes your numerator. 6 becomes your denom. Fraction, please. 15 over log of 6. Now remember, 6 to the something equals 15. I can't simplify that. So I use change of base. When something's not easy to be simplified, use change of base. What's this decimal answer, please?
1.5.
Again?
Yep.
Really?
Uh-huh.
I made these up off the top of my head, but I don't like that they're the same thing.
Why does the next one be 1.5?
Oh my gosh. Log 30 over log 3.
10.
No, you can't say 10 because it's actually like they're decimal numbers.
1.5.
3.1?
Yeah.
Okay. Last one. Is 2 to the something equal to 17? Can you think of it in your head? No. So use change of base. $4.08. Okay. So change of base is when I say, simplify, but then you're like, I can't figure out what the exponent would be. changing to the same base. Okay, real quick. This would become 6 times log of 5. Ooh, 2 plus log of 5 of x. See how 2 times x, you make it a plus sign. The 6 would go in front. Oh, the 6 would go in front of just the x. Oh no, I messed up. The 6 goes in front of just the x. It's not 2 to the 6th. My mistake. B. 9 times x. Make it an addition problem, right? Okay. C is lot. I'm going to make you stop at C. Okay. Ready? The 4 times x becomes an addition problem.
What?
Because it's 4 times x.
Oh, I just did log 3 for x.
So I did log 3 of 4 plus log 3 of x. And then since it had a fraction, I'm going to do a minus sign and just do log 3 of 5. That's tricky.
Can you do that and put the log 4 and the log x in parentheses?
Yeah, that would actually be helpful too. If you think of it, you know. But again, they're the first 2 listed, so you go in order. We'll stop with that. That's tricky, right? You're playing around with these numbers. You're using properties of exponents. So your task right now is behind this paper that I just gave you. And since there's so many, I wanted to have you start. It really is only 13 through 19. It's not 1 through 19. So it's 13 through 19. Expand. Use the rules of logarithms. I will put them on the board for you. I'm going to stop the video.